Hello everyone. This video is in continuation of our series environmental sciences, in which we started from the first subject that is atmospheric chemistry, air pollution, and climate change. So this was our first subject to be covered in this series, and in this subject we started with the structure of atmosphere, which is basically on the basis of temperature and pressure profiles. We have layers such as troposphere, stratosphere, then mesosphere, and thermosphere. So this was the structure of the atmosphere based on the temperature and pressure profile. So further we are going to discuss the chemical composition of atmosphere. So on the basis of chemical composition, the atmosphere is divided into two layers, that is homosphere and heterosphere. So going further, why this is called as homosphere? This is called on the basis of chemical composition. Atmosphere is divided into two layers, that are homosphere and heterosphere. So this homosphere is basically extends from 0 to 80 kilometers. Why this is called as homosphere? Because of the homogeneity of the proportion of various gases. In other words, the proportion of different gases are uniform at different levels in this zone. So in homosphere, the proportion of different gases are uniform at different levels. Say for example, homosphere represents the lower portion of the atmosphere and extends up to height of 90 km from the surface. So this uniform composition is depicted in this table, that is nitrogen is 78% by volume, oxygen is 20.9%, that is 21%, then we have argon, that is 0.93%, then carbon dioxide, which is about 0.042%, and then we have neon, then we have helium, we have methane concentration by volume, then we have krypton, nitrous oxide, then we have hydrogen, then ozone. So these components of the homosphere are these components of the the homosphere. Homosphere are more or less uniform and are presented in this table. So you can check the concentrations. Although the main, that is the humans, are increasingly disturbing the natural proportion of gases through his ever increasing economic activities and modern technologies. We say that the homosphere is uniform in its components, but it is said that man is increasingly disturbing the natural proportions of gases from his ever increasing economic and activities and modern technologies. For example, the proportions of carbon dioxide is rapidly increasing due to the burning of fossil fuels such as coal, petroleum, and natural gases, and deforestation. So the proportion of carbon dioxide is rapidly increasing due to burning of fossil fuels and deforestation. It has been reported that the concentration of atmospheric carbon dioxide at the beginning of the Industrial Revolution in 1860, when the Industrial Revolution started, the concentration of carbon dioxide was fixed at 280 to 290 ppm, parts per million, by volume, but now it has increased up to 420, 422, 430 ppm. It is this concentration 420 to 430 is reported in a recent report of IPCC 2022. So at the beginning of the Industrial Revolution, before 1860, the concentration of carbon dioxide was 280 to 290 ppm, but now it has increased up to 420 to 430 ppm in 2022, thus registering an overall increase by 20 to 30%, 25 to 30% from the pre-industrial level. So this is basically the homosphere of the atmosphere. We can repeat this, that we have started with the structure of atmosphere, in which we have seen that atmosphere is divided into several horizontal layers such as troposphere, stratosphere, then mesosphere, and thermosphere. This was the structure of atmosphere. Now the composition of atmosphere. In composition of atmosphere, we have studied that the atmosphere, on the basis of the chemical composition, the atmosphere is divided into two layers. One is homosphere, in which the concentration of different components components such as nitrogen, oxygen, carbon dioxide, argon are more or less uniform and homogeneous. That's why this lower portion of atmosphere is called homosphere, right? So basically homosphere extend up to 0 to 90 kilometers, in which the gaseous component are uniform and homogeneous. So the second layer is heterosphere. Heterosphere. So heterosphere extends from 90 kilometer to the upper extent of the atmosphere, that could be 10,000 kilometer or 1,000 kilometers. Different layers of this sphere vary in their chemical and physical properties. So this heterosphere is further divided into sublayers based on the composition. So the very first layer is the molecular nitrogen layer, is dominated by molecular nitrogen and extends upward up to the height of 200 kilometers, that is from 90 to 200 kilometers. So the second layer is atomic oxygen layer, which extends from the 200 to 1100 kilometer. Then further we have the third layer, which is helium layer, which extends up to the height of 3500 kilometers. So the fourth layer is atomic hydrogen layer, is the topmost layer of the atmosphere. So the sequence of these layer is basically the lowest one is the nitrogen layer, the lowest one is the nitrogen layer, the second one is the oxygen layer, number third is the helium layer, and number fourth, the topmost layer is the hydrogen layer. So why the sequence of these layer is in this way, that is from nitrogen to oxygen to helium and hydrogen. So this is because the heavier the molecular layer, the lowest place it will occupy. So as we move upward, the oxygen is lighter than nitrogen, then helium is lighter than oxygen, and hydrogen is lighter than helium. So therefore they occupy the atmosphere in this sequence, starting from nitrogen, which is the heaviest, then followed by oxygen, then followed by helium and hydrogen. So these are the different layers of the heterosphere. These are the different layers of heterosphere. Starting from the molecular nitrogen layer, then we have atomic oxygen layer, then we have helium layer, and the atomic hydrogen layer. Based on their weight, they are arranged in this sequence. So with this we have with this we have done with chemical composition of atmosphere.